Okay, today we're going to be learning about lesson 8-8, which is completing the square, day number 1. Just to give you a heads up, this is a very, very challenging skill in the Algebra 1 curriculum. That's why we're going to be covering it today, tomorrow, and Thursday. So how it's going to work is we're basically going to break up the whole skill of itself over 3 days. So we're not really going to be doing complete the square today. We're just going to be solving some equations and looking at what it looks like, okay? So the first thing we're going to look at is blank times blank equals 9. I want you to try to figure it out. So while I go through it in my head, 1 times 1 is 1, 2 times 2 is 4. Ooh, 3 times 3. That gives me a 9. So I'll do a 3 and a 3. Here's the issue. Negative and a negative make a positive. So I can make these 3's negative as well. So negative 3 times negative 3 equals 9 as well. So not only do I have 3 times 3, I also have negative 3 times negative 3. So if I had x squared equals 9, the values of x could be 3 or negative 3. So we're going to write that in. So I could actually have 3 and negative 3. Here's the issue. Mathematicians are very lazy. We don't like to write numbers that are the same twice, just one positive, one negative. So we're actually going to switch it up a little. We're going to actually write this plus or minus 3. That would be your answer for the values of x. So we say that simple as plus or minus, where the plus is on top and the minus is below. So what we're looking at today is we're actually going to be looking at how to solve quadratic equations. And I'm going to give you a heads up. Some quadratics are actually fairly simple to solve because they are in this form, quantity x plus or minus something squared equals yada, yada, yada. So the only procedure you have to do for these problems is take the square root of both sides to solve for x. So here's our first example. I have x minus 4 squared equals 9. My first step is just take the square root. Take the square root of the left, take the square root of the right. I'm giving you a heads up. Every single time you take the square root of something that's being squared, it cancels. So I'm just left with x minus 4 equals plus or minus radical 9. So I say to myself, what makes 9? 3 and 3. So this radical 9 is actually radical 3 times 3. Remember, double on the inside, single on the outside. So x minus 4 equals plus or minus 3. Ooh. X minus 4 equals plus or minus 3. Now to get rid of my 4 that's being subtracted, I add 4 to both sides. So my negative 4 and 4 cancel, so I end up getting, I'm going to move over to the right, x equals 4 plus or minus 3. So you say to yourself, I want to find out what x is, so x equals 4 plus 3, and x is also equal to 4 minus 3. 4 plus 3 is 7, and 4 minus 3 is 1. Those are your values of x. X equals 7, and x equals 1. So you have 2 possible answers. So before we go into the lesson part where we solve a few more of these equations, I'm going to just list a few of the perfect squares. So perfect squares are numbers that I multiply by itself to get a different number. So 1 times 1 is 1. That's a perfect square. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and then so forth. So you should know these. You should memorize the first few perfect squares, like 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, and then 12 times 12 is 144, and then so forth. So I have a bunch of these perfect squares. The reason why it's important to memorize your perfect squares is because they actually can make solving radical questions a little easier. So for instance, if in that previous example, how I had radical 9, if I have radical 9, I can just say radical 9 is equal to plus or minus 3, because 3 times 3 is 9. I can also say radical 25 equals plus or minus 5, because 5 times 5 is 25, and negative 5 times negative 5 is 25. All right, so what if I were you? I'd write down all your perfect squares right now, so the video is pausing. The reason why you should write down the perfect squares is because guess what? The first two examples we're dealing with today actually are perfect square examples. So we're going to be going over quadratic equations that come about in 3 different forms. Ones where there's perfect squares. So let's do our first examples where we actually just deal with perfect squares. So make sure you know your perfect squares. So x minus 5 squared equals 4. The minute I see that square, I want to take the square root of both sides. So I take the square root and I take the square root. Remember, every time I take the square root of a square, it cancels. So the square root of x minus 5 squared is just x minus 5. And that's equal to the square root of 4, which we said is just going to be plus or minus 2. The next step, to get rid of that minus 5, we add 5 to both sides. Remember, we always have to take into account that plus or minus. So add 5, add 5. My 5s cancel. So I end up getting x equals 5 plus or minus 2. Here's the issue. On the Regents, that is acceptable typically as your final answer. You could leave it like that on the short answer. But what I want to tell you right now is that for our class, for the time being, since we aren't taking the Regents this year, you'll be taking it next year, is to basically sort of look at it like this. I see a plus and I see a minus. That means I have to have 2 different answers. So I have 5 plus 2, and then I have 5 minus 2. What's 5 plus 2? You guessed it, it's 7. And then 5 minus 2 is 3. I have 2 different answers. I have 7 and I have 3. Using that information, I think you should try to do example number 2 by yourself, or you can watch me solve it and follow along. So I have x plus 2 squared, the first step. It's equal to 49. I take the square root of both sides. The square root of x plus 2 squared is just x plus 2. And that's equal to the square root of 49. What times itself is 49? You got it. It's plus or minus 7. Plus or minus 7. How do I get rid of that plus 2? You got it. Minus 2. Minus 2. 2's cancel. I get x equals negative 2 plus or minus 7. I break it up into x equals negative 2 plus 7 and negative 2 minus 7. Negative 2 plus 7, I break it apart. If you don't know how to do negative and the addition in your head, just use a calculator. I get 5. You should not be using a calculator, though, for this section. You should only be using it if you absolutely need to. The SAT actually has a section on the test where you're not allowed to use a calculator. Negative 2 minus 7, traveling deeper into the negative numbers, is negative 9. I have 2 distinct answers. X equals 5 and x equals negative 9. If you missed anything, write down it now so we can go on to the next page. Ones where, one second, their radical does not simplify. And then ones where you have to get that radical in simplest radical form. Boom. So in this section, we're going to be taking the square root of numbers that don't simplify, as in it'll just stay as that number. So let's do the first example. I have x minus 4 squared equals 5. solve this equation, I take the square root of both sides. The square root of x minus 4 squared is just x minus 4. And that's equal to plus or minus radical 5. I now say to myself, can I break up a radical 5? So if you want, what I would do is do the prime factorization. So 1 times 5. Here's the issue. They're both prime. There are no doubles. There's no doubles. They're all singles. So remember, in order for it to go on the outside of my radical, it has to be a double. So because of this, I can't break apart a radical 5. So I just get x minus 4 equals plus or minus radical 5. So I say to myself, how do I solve? Well, add 4 to both sides, and I get x equals 4 plus or minus radical 5. That's it. You can leave it just like that. X equals 4 plus or minus radical 5 is your final answer. Now let's go on to the next question. If you want, it's the exact same way as we did question number 1. You should maybe try this one by yourself. Now with this example, I have x plus 6 squared equals 10. The first step always is just take the square root of both sides. So I take my square root. The square root of x plus 6 squared is just x plus 6. And then I get equals plus or minus radical 10. I say to myself, can I break apart a radical 10? I get 2 and 5. There are no doubles, so I can't even do it. So remember, double on the inside, single on the outside. I now take away 6 from both sides. 6 is canceled, so I get x equals negative 6 plus or minus radical 10. You don't have to type it in your calculator or anything, you just leave it like that. Now let's go on to the next example, where we have non-perfect squares that actually do simplify into a simplest radical form. Again, the procedure is the same. Take the square root of both sides, so I have x plus 6 squared equals 50. The square root of x plus 6 squared is x plus 6, and then I get plus or minus radical 50. One thing I like to do with these questions is actually go to the side and do the work for my square root over there. So the square root of 50 I can break apart into 25 and 2. 2 is prime, and I can then break apart 5 and 5. They're both prime. So this becomes radical 5, 2. And I have a double, my 5s. So 50 is really just 5 radical 2. So I'm really solving x plus 6 equals plus or minus 5 radical 2. To get rid of my 6, I subtract from both sides. Take away 6, and I get x equals negative 6 plus or minus 5 radical 2. That is your final answer. We cannot combine the negative 6 and the 5 radical 2 because the negative 6 doesn't have a radical 2 attached to it. If I were you, I would try to do the second example by yourself. So I have x minus 2 squared equals 18. Take your square root, The square root of x minus 2 squared is just x minus 2. And then I get equals plus or minus radical 18. Go to the side, find out what radical 18 is equivalent to. Break it apart. I get 2 and 9. 2 is prime. Break apart the 9. I get 3 and 3. Boom, 3 is prime. So I get radical 2 times 3 times 3. I have a double, and it becomes a single on the outside. So I get 3 radical 2. Using this information, I change my radical 18. So I have x minus 2 equals plus or minus 3 radical 2. To get rid of my minus 2, I add 2. 2's cancel, so I get x equals 2 plus or minus 3 radical 2. That is your final answer. So those are the situations you're going to run into today. So when you do your independent practice, there's one example of each situation. If you have any questions, please don't hesitate to email myself or Ms. Townsend. Don't forget to work on your independent practice. Today is Tuesday. It'll be due on Thursday. And it's only 3 questions. So if you want, you can work on it today. I'll be holding extra help tomorrow from 3 to 4. So if you want, we can work on this then. But remember, make sure that you are working on your independent practices. If you have any questions, make sure... Oh, also, make sure you write down your daily question on the Google Classroom so we can make sure we capture your attendance. Okay, I think that's it. Have a great day, ladies.